how to figure out the answer to this absolute value problem simply by graphing. So when we look at this kind of absolute value problem, let me just reiterate that these straight up and down bars mean we're going to perform an absolute value function. An absolute value function is the same as distance. So what we need to do is we need to draw our number line, and we need to put some strategic points in there. So what we need to do is we need to figure out where the center is. Well, our center value is the opposite of what we see here. So our center value is going to be 3. So I'll put 3 right in the center. So this is where we start. That's our center. And it's whatever the opposite is that we see in here. And absolute value is a measure of distance. So 5 is our distance. So that means that we want to go 5 units to the right, 5 units to the left. So if I go 5 units, I go 1, 2, 3, 4, 5. I end up right here. And if I go 5 to the left, I go 1, 2, 3, 4, 5, and I end up right here. I'm going to extend my number line here a little bit so it doesn't end right at the value that I'm interested in. Okay, so what's this value here? Well, this would be 3, and if I go 5 more, that would make this 8, because 3 plus 5 gives me 8. Now I'm going 5 this way, so I'm going to count backwards. So this is 2, 1, 0, negative 1, negative 2. So this value here is negative 2. So if I had 3 minus 5, it's the same as negative 2. Because this is an equals, that means it's exactly equal to, so that's my solution there. And that's my solution there. So if I were going to write this in set builder notation, I would say the set of x such that x equals negative 2 or x equals 8. And there's my solution. So let's try an inequality. So here we go. We have an absolute value of q plus 7 is less than or equal to 3. So what I'm going to do is I'm going to draw my number line. And I have to figure out what my center is. So I know my center comes from here. And I should point out that notice our coefficient here is 1. I don't have another number there, so it makes it easy for me to do this. So that means my center is opposite of what I see here, which would be negative 7. So my center is negative 7. And absolute value, that's what these bars mean, is a measure of distance. So this over here is my distance. So that means I can go 3 to the right, 3 to the left. 1, 2, 3. So that would be negative 7, negative 6, negative 5, negative 4, which is what negative 7 plus 3 would be. And then I'm going to go 3 to the left. So this would be negative 8, negative 9, negative 10. Okay. So when I'm looking at my inequality, I see I have this equals bar here, which means I'm going to have those points included as part of my answer. So I color in the circles here. Now I have to ask myself, I want my distance, because remember, my absolute value is distance. I want my distance to be less than or equal to 3. Well, remember, this distance here is 3, isn't it? So if I want to be less than, if I have a value right here, well, that's less than 3. If I have a value right here, That's less than 3 from the center. So I know everything through here is going to be make that less than 3. The distance is less than 3 through here. This distance here is also 3 from center. So I know if I'm right here, my distance right here is less than 3. My distance right here is less than 3. And all the numbers in between there. So I have just graphed that function. Now, we want to write this in set builder notation. So where is my x? Well, my x, or in this case, gives me my q, is anywhere along this part of my line segment. So my x lives anywhere in this region. The largest it can be is -4. The smallest it can be is -10. So -10 is less than or equal to x, and x is less than or equal to -4. So notice that these are facing the same direction. If I were to get rid of x, isn't -10 less than or equal to -4? So that there makes sense to have those inequalities facing that direction. Okay, so now I'm going to go ahead and write my set builder notation. The set of x such that -10 is less than or equal to x, which is less than or equal to -4. So that tells you that x is everything in between -10 and -4, including -4.